Okay, the question is in description. So as we can see, the logs are stacked in layers where each layer contains one log less than the layer below, and there are 5 logs in the top layer, so and 6 in the next one. So if we look at this formula, so if we assume that the top layer is the first layer, so basically the logs are like that, they're stacked like that, and similarly it goes for some layers. So there are 5 of them in the first one, then 6, then should be 7, so we can see that the difference is 1. So the question is, what is the number of logs in the bottom layer? So, and it's also said that there are n layers altogether, so the layers are n layers, so what we can say, a is 5, so 5 plus n minus 1 into 1, so 5 plus n minus 1, which is n plus 4. So the bottom one will have this many logs, because this is the nth term, which is the bottommost term, that is this many logs the bottom one has. And we have to show that there are, what's the total number of logs. So this one has 5, this one has 6, in total these two has 11, like that. So the sum of is, we know, n over 2 2a plus n minus 1 into d. So n over 2, because our number of layers are n anyway, and this one has 5 plus n minus 1, and d is again 1, so we can just do it. So this is n over 2 10 plus n minus 1, which is n over 2 n plus 8, and sorry, n plus 9, and that's the answer. Yeah, so that's what we needed to prove. So yes, so this is where the tap is. The question is in the description, and the stable hand, to fill up the first trough, she has to come from here to the tap and then carry away. So she has to walk for 4 meters. For to fill up the second one, she has to go up to there, that is, and then come back there. So that's 6 plus 4, that is 10. For the third one, she has to do this 10 plus 6 more, so 16. So this is how she goes. So the question is, the first question is, how far does she has to walk to fill the kth trough? So that is, what is the kth term? Because for the third one she has to walk this much. How far she has to walk for the kth trough is the kth term. So for third one she has to walk this much. Second one she has to walk this much. If we can find how much she has to, the kth term, we know that this much she has to walk to fill up the kth trough. So let's do that. So that's a plus n minus 1 into d again, that formula, which is term k. So here actually it will be instead of n, it is k. A is 4 plus k minus 1 into difference is, we can see difference is 6. So 6. So that is 4 plus 6 k minus 6. So 6k minus 2. That is the amount of work she has to do. This much meter. Okay. Now coming to the second one, I will just erase this part. How far does the stable hand has to walk to fill up all the troughs? That means she's filling up first trough, and she has to walk 4. Then to fill up the second trough, she has to walk 10. Then third trough 16. To fill up all the troughs, that is all n troughs, she has to, how much she has to walk we can find by summing them all up. So we actually have to find the sum, which is n over 2 2a plus n minus 1 into d, so that's n over 2, 2a is 2 into 4, that is 8, plus n minus 1 into again 6, so that's n over 2, 8 plus 6 n minus 6, which is n over 2 6n plus 2. If we take 2 out, it will be n into 3n plus 1, which is 3n square plus n. That much meter she has to walk to fill up all the n troughs. Now, if the stable hand has to walk 1220 meters to fill all the troughs, how many water troughs are there? So we just equate this one to 1220, and if we solve it, we will find the number of troughs. So I will just erase again this much. So it's just equating that to that and then finding the values. So yeah, 3n square plus n is equal to 1220. So 3n square plus n minus 1220 is equal to 0. So if we just use that formula for solving quadratic equation, we can find the solution. So yeah, I won't do the solution here, I will just write the results. So we get actually n is equal to 20 and the other value is 61 over 3, but this one can be ignored because this is negative, so there are 20 troughs. That's the answer.